Yeah, g'day YouTubers. Tinker O'Toole again here with another video. Today we're going to talk about how a chainsaw chain actually cuts timber. It may not be what you think it is. Traditionally, when we used to cut timber, it was done with a saw. So we have a saw blade, it was referred to as a blade, and on the blade you have little teeth that are fixed. That's the way that all saws used to work until the chainsaw came along. So the chainsaw has movable little teeth that rotate around the bar. And it doesn't even work, like a lot of people may not realise it, but it does not work like the traditional saw teeth on a blade, like I just showed you. Because the teeth travel along, and when they strike a bit of timber, they have this rocking motion. They rock up and down like little dolphins going in and out the water. That's the best way it's always been described. So as the tooth comes around on the bottom of the bar, as you lower the bar on top of the log and they strike timber, they have this rocking motion like this. Because as it strikes the timber, it digs in, and when it digs in, there's a little bit of slack that's in the chainsaw, like it's not real tight. It tends to dig in until the raker prevents it from digging in anymore. And because of the rotational forces, it pulls the chip out like that. Goes along and then does it again when there's a little bit of slack in the chain. That's why you've got to have the right chain tension. Have the right chain tension, that rocking motion will work perfectly. And you end up with all these little chips all over the place. So that's the way it works. It does not cut as in the true sense. It takes out little thousands and thousands of chips, like someone that's got a pick and digging into the soil. They're just picking away at it, and the chain does exactly the same thing. Every little cutter comes along, whether it's a left-hand or a right-hand cutter, digs in and takes a little chip. And it's the raker that actually governs the height of the chip. Because if you didn't have the raker, it would just dig in and it would just stall. So, and I've got a little tooth here, and you can see exactly what that tooth's doing. Now, what's also interesting about that is you can see there that it doesn't dig in that much. Even though that the raker height's set to approximately, this is a brand new tooth, even though that the raker height is set to 0.65 of a millimetre, sometimes it digs in a little bit more than that. So through the forward motion, it'll take the chip out like that. There's the chip there. Another little tiny chip. And if you have a look, that's what you're left with, that little. But you notice it's deeper on one side because the actual tooth, the point of the tooth will dig into the timber first. So if I was to use my thumb and push that in, you can see that the point of the tooth, there it is there, starts to dig in. Try and do that again so you can see that a little bit more clearly. Doesn't take a lot of force, but if I push that tooth and lift it up, there it is. There's a little chip. And that's exactly how it works. That little tiny chip will just drop it down here next to that one. There it is there. So that's the way it works. And you'll see it in the high-speed video at the end. Now, a tooth, this is a 3/8 standard tooth, approximately about 10 millimeters in length. Just try and focus on that. It's about 10 millimeters in length, and it's got a height. If we look at the height from the bottom of the gullet to the top is about 5 millimeters, and the width is 4.5 millimeters. It does need that height clearance to get rid of the chips, because there's approximately over 25,000 chips per minute. That's a lot of chips. And it's got to be able to get rid of them. And when the chips are being dug out and it's in the channel of where the saw is running, the chain is running across the log, there's no room to escape because you've got the side walls of the log that it's already cut into, and all the chips all back up. This is why you need the clearance. By the time that the tooth comes out of the log, then the chips come out freely. They've got much more room to evacuate the chain. And the process keeps continuing. But while it's in the log, this is why sometimes if you have timber that's a little bit wet, it can totally block up. I've had that happen before. The whole chainsaw gets bogged up with chips and it just jams up. Doesn't happen often, but it does happen. So the other thing is, what's really important, we've mentioned about that if we look at a chainsaw tooth, the height from here to here is approximately 5 millimeters, and it needs all this space to get rid of the chips. Quite a lot, because, as I said, if the chips start to get compacted, then it can slow the saw down. And through the motion of traveling at 100 kilometers an hour, the mechanical, just the size of the chain is enough that they get caught on the raker, they get caught on the next tooth, and it just drags all the chips through until they evacuate. So there's no special, a lot of people think that the gullet helps stop the chips. Look, a little bit of bumps on the gullet's not going to do anything whatsoever. Contrary on what you may have heard about get the gullet or whatever, I think that's not exactly quite true. Admittedly, I try and get rid of that little ski jump. A lot of times when you buy a brand new tooth, you'll see this little bit of a ski jump here. Yeah, look, I try and get rid of that, but I don't think it's as critical as what some people make out. Now, what I wanted to show you and talk about was, we just spoke about how the tooth works. And if we talk about this distance between this point and the point of the tooth, there's two things in here that I want to talk about. And that is the height of the tooth in relation to the height of the raker. Then you've also got the distance from the raker, the point, to the point of the tooth. Those two things are very important. There's two types of raker gauge tools that are available out there to set that, because they have to be set not every time you sharpen the chain, but every couple of times that you sharpen the chain, they need to be checked. Now, you've got a constant depth gauge like this. This is referred to as a constant depth gauge because you'll notice here it's got 0.65 of a millimeter. And what that means is that when you sit this gauge over your chainsaw, the raker, if it protrudes through this gap here, you'll get a flat file and file over the top. So this type of gauge will only ever maintain a differential height from the top of the tooth to the top of the raker of 0.65 of a millimeter, from being brand new to the end of the life of the tooth, which is down on the witness mark, that's what we refer to as a witness mark. But what happens when we file the tooth down? This distance from here to here increases. And because of that increase, leverage on the rivet, the way that it pivots, changes. And we go from approximately 6 millimeters being brand new from this point to this point. By the time we get down to here, it's about 12 millimeters. And the pivot point now, you'll notice at the pivot point is right in front of the tooth, whereas when we get down to here, the pivot point is almost right in the middle of the rivet. So this tooth, the sensitivity of the rocking motion changes. And also, the other thing that changes, so if the rocking motion slightly changes, the other thing that changes a lot is what we refer to the attack angle. In woodwork and metalwork, everything has an attack angle. In golf, you'll hear about attack angle all the time. And that's where the golfer spreads his legs and puts the tee and the golf ball there right between his legs. And he has to strike the golf ball exactly at the right angle so he gets the longest distance. Attack angle's used in a lathe. The actual cutting bit has to be at a certain angle, especially if you've got stainless steel or aluminium. Otherwise, you get too much chatter. When you use an axe and you strike into the log, that's an attack angle. So we use attack angles everywhere, and a chainsaw is no different. So this angle here that the raker sets is referred to the attack angle. The best attack angle for a chainsaw is around 6.3. You will get 6.3 degrees using one of these gauges when the chain is brand new. By the time you get to the end of the life, what's going to happen? This attack angle is going to diminish down and get less and less. And you'll end up with an attack angle of 3 to 3.5. An attack angle of 3 or 3.5 won't cut very good. You'd be lucky if you get 60% cutting efficiency, because you're only taking the 0.65 of a millimetre off, but this distance is getting further and further away. The tooth is getting further and further away from the raker, and as I say, it's almost double by the time it gets down there. Now, this type of gauge was invented by Joseph Burford Cox in Portland, Oregon, over in America. And he put a worldwide patent on it, but his gauge had, I think, 25 thou at one end and 30 thou at the other end. And he had a few variants of them. He had an adjustable one, which would have been fantastic if it was available today. But Joseph Cox sold that company, and it's owned, I think it's been sold twice, and it's owned by Blount. The gauge they have today is nowhere near as good as the gauge that Joseph Cox invented, because it was a hardened gauge back in those days, and the one that they've got these days is all soft metal. This one by still is far superior because it's hardened, and it's got a Rockwell hardness of about 60, and a file's got a Rockwell hardness of about 62, so you won't file this. You run the file over the top, so don't be afraid to do that, because you won't file it away. But as I said, this was invented and got a worldwide patent on it, and everyone just copies it these days because the patents run out. But there was a man called Ray Carlton who used to work for Joseph Cox, and he left. I don't know exactly what year he left, and he invented his own company. And you may have heard of Carlton Chain, which is also owned by Blount. And he invented the progressive depth gauge and called it Philo plate. Now, the progressive depth gauge looks a little bit like something like that. Actually, it looks like the Lego man. If you look at it like that, it looks like the little Lego man. But what it does, rather than sit on 4 teeth and pop through the little window, it sits on 1 tooth. And the way that it works, as the tooth is filed backwards, this angle leans down more. So the attack angle goes from being around 6, and it will lean down like that. Now, when it leans down like that, as I said, the distance gets a lot longer on the tooth as we file it back. You'll find out that the raker will protrude through the little window. So this will keep the attack angle around 5 at least by the time you get to the end of the life, not around 3. So it'll be either 5, 5.5. It'll maintain it really good efficiently. So it is superior because it maintains that attack angle. Your cutting efficiency doesn't drop off. And in actual fact, your cutting efficiency will go up because the kerf, which is the word that we use to describe the width here, is actually wider. It's about 4.5 millimeters in width at the widest point, and at the bottom, at the end of the life, it's about 3.9 millimeters or 4 millimeters. Depends on the chain manufacturer how much angle they want to give it, because they give it the angle so it's got better clearance. So it brings us back to the point, now that you know a little bit about raker gauges and depth gauges and how they limit the amount of depth that they cut into the timber by the raker. So when we have a look, and we'll just see if we can zoom in a little bit better than this, because the next thing I want to talk about is how efficient or inefficient parts of the chainsaw tooth. So when we look at a chainsaw tooth, this is a full chisel, and a full chisel is much more aggressive than a semi-chisel because of the square shoulder and because of the working corner, the point. And it's this little point that we see here. It's this little point that digs into the timber first, because if you look at the top of the tooth, the top plate, you'll notice that it's on an angle. It's roughly about a 25-degree angle on a full chisel, and it's 30 degrees on a semi-chisel. And because it's got a point on it, that's the first part that digs into the timber. So if we go back to a tooth like this, because of this angle it's on here, so the full chisel is 25-degree angle, in our little demonstration where we had the block of wood and the little tiny tooth, it's this part that digs into the timber. And because of that, it digs into the timber over this side, and this part barely digs into the timber. So that's how it takes a chip out. And you could imagine that on a milling, it's nowhere near as aggressive as this, so it's not as aggressive, and you don't want it too aggressive on a mill because the surface of the timber would be a little bit rough. So you want it as smooth as what you can get it, so they limit the aggressiveness of the cut. So, as I said, as this pushes into the timber, it pushes in, and as you saw on the timber, it takes a little chip out. But the actual tooth itself does not go very deep into the timber. It'd be lucky, even though that the raker, the height is set at 0.65 of a millimetre, being brand new, it can penetrate a little bit more than 0.65 of a millimetre, probably up to about a millimetre. Because it depends on how hard or soft the wood is. The softer the wood, it will penetrate a little bit more because the raker will sink into the timber a little bit more through force. Being so skinny, if the raker, the width is skinny, it can penetrate into the timber, especially if you're pushing down on the saw a bit. So therefore, what is important now is that no more than 2 millimetres. You can see this angle here. This angle is dead straight. It's only about the first millimetre or so of the tooth that actually ever penetrates the timber. The side plate does not penetrate the timber, but it works like a barber's shaver. It'll shave off, or cut, whichever word you want to use, any loose fibres there. So if there's a little bit of a fibre or a little bit of timber there that's on the side, it'll just penetrate through that, making it much easier to sever the chip from the log. So the side plate down here really does nothing. It really doesn't do much at all because it doesn't go even into the timber this deep. As I said, if you look at a side plate and you're to measure it, it's probably just over 3 millimetres in width. Actually, we could measure it. And it's always best to have a little bit more of the tooth, the point, so that it can go into the timber a bit deeper. But if we do measure it, oh, I've got one tooth here. I'll measure this one. 2.76 millimeters. And if we're to measure three point 3.27. So you've got 3.27 millimeters of side plate that you can play around with. And even if we bring it closer, you can see that point. Now look at that. So that straight section that I'm talking about, you can see here that it's lucky if it's just a fraction over a millimeter. Look at it. That's a straight section there. And then it curves all the way down. So that's the most important part. And you can see how easily that point goes into the timber. And this part here enters the timber first. By the time you get over here, it really doesn't, there's very little that enters the timber. This part digs in first. And that's why you'll see the chips sometimes a little bit more timber on one side than the other side, because of this part that does dig in first. It depends on, look, a lot depends on how you're cutting and how sharp it is. Now, this particular chain here is still Hexa, and we'll just turn it around the other way. That's the way we had the other one. And as you can see, there's a familiar pattern there. We'll just bring another tooth in there. And again, you'll see that hexagonal shape, but you'll notice on the still Hexa, it probably comes down on the side plate a little bit more than that was Husqvarna's X-Cut. So when you look at it there, it's coming down on the side plate about 70%. So that'd be a good 2 millimeters there. Maybe a little bit more than that. But the other thing is, it'll never go into the timber 2 millimeters. So that's the whole point. Now, when we spoke about the rakers before, and we spoke about how a progressive depth gauge will change the way, the depth of the raker. So from brand new, and we've got this distance here, we mentioned that by the time it gets down to here, it's about 12 millimeters from this point to that point. The other thing that happens is, remember I said the attack angle will be kept roughly the same, around 5, 5.5, something like that. We need to reduce the height of this progressively until we get down to this point. When we reach this point, the distance from the top of the tooth to the raker at this point down here will be 1.2 millimeters in depth. So the raker height differential between the top of the tooth and the top of the raker will be 1.2 millimeters, almost double. But so is the distance of, this is approximately 6 mil, but it'll be 12 mil by the time it reaches there. So the attack angle is maintained. You need to reduce that raker so that that attack angle is changed. And nothing changes. Even though it's 1.2 millimeters, it still won't go into the timber much more than a millimeter because of that attack angle. Attack angle is everything. And a good example of an attack angle is if you were to use a splitting axe, and that's why it's called a splitting axe, it's much easier to split going with the grain. If you were to use an axe across the grain at 90 degrees, it's not going to cut into it very good at all. If you hold the axe at 45 degrees against the grain, which is what most axemen do at about 45 degrees, then that's the cutting angle that it penetrates the timber. So for this tooth to penetrate the timber efficiently, it's going with the grain, or sorry, we're going against the grain if we're cutting a log. And going against the grain is a lot easier to get the chisel, because really that's what it is. It's like a chisel. So we'll refer to it as a tooth. The tooth, the point of the tooth penetrates under the timber a lot easier if it's got a sharp point. So the biggest downside on using the full chisel is that this point becomes a lot duller, a lot quicker than a semi-chisel, where the semi-chisel has that nice rounded corner. The semi-chisel does exactly the same thing, but it doesn't do it as efficiently as something like this. But as I said, if you use this in dirty timber, it'll go blunt very, very quickly. But interesting enough, when you look at it from this angle here, it looks like a spear. And that's what it does. You can see at that angle there, it looks like a spear, and it'll penetrate the timber quite easily than a semi-chisel will. So I hope that really explains how a chainsaw cuts timber. It doesn't work like a normal saw. Each individual tooth works like a little pick and takes a little chip out. And that's the way that it gets through a log. It doesn't saw through like a conventional saw. Every tooth takes a little chip left and right, and creates a channel until it cuts through the log. And that's it. But watch this video that's on the end of this, and I think you'll find it very interesting. It's high speed. You need to look closely, especially when it gets about halfway through the video. In the beginning, it's not cutting into there very deeply, and they only use a little bit of softwood. Looks like birch or something. But you can see the cutters jumping up and down. You can see that movement, and you can see the fibres flying all over the place. Anyway, it's not a bad little video. There's not many on that I've ever found. This is the only one that I've found so far that sort of goes into detail on how it works. Anyway, watch the video, and I hope that you enjoy. Bye for now.